Like vector addition and subtraction, the dot product has several algebraic properties. Let's consider vectors u, v, and w, and scalar c. Then the following properties hold. The commutative property tells us that the order of the vectors in a dot product does not matter. That is, u dot v is equal to v dot u. Because the dot product is the sum of the products of the corresponding elements in the two vectors, this follows from the fact that multiplication is commutative. The distributive property states that the dot product of u with the vector sum v plus w is equal to the dot product of u and v plus the dot product of u and w. This property looks like the distributive property for real number multiplication, but with each term in the sum on the right still a dot product. The associative property states that if a scalar c multiplies the dot product of u and v, the result is equal to the dot product of the scalar multiple cu and v. It is also equal to the dot product of u and the scalar multiple cv. This property also looks similar to the associative property for real number multiplication, but with dot products. The fourth property gives us a relationship between the magnitude of a vector and the dot product of the vector with itself. Namely that the dot product of a vector with itself is equal to the square of its magnitude. In this example, we are asked to evaluate an expression involving dot products of vectors a and b, and scalar multiples of these vectors given only the magnitude of one of the vectors. We will need to apply several dot product properties. We begin by using the distributive property to remove the parentheses. This allows us to write the initial expression as the dot product of a and 2b plus the dot product of a with itself minus the dot product of b and 2a. Then we use the associative property to rewrite the dot product of a and 2b as twice the dot product of a and b, and to rewrite the dot product of b and 2a as twice the dot product of b and a. The commutative property is then used to reorder the vectors in the third dot product because b dot a is equal to a dot b. We now have like dot product terms of equal but opposite sign, which allows us to simplify the expression. Now that we have a dot product of vector a with itself, we can use the property of magnitude, replacing a dot a with the square of the magnitude of a. Finally, we substitute 10 for the magnitude and simplify the result. So, the expression is equal to 100.